Hi, so today I am teaching 4.1 determination of moments from force and couple. And so I have two problems here. This problem on the left is force. Okay, we're going to determine the moment around point O based on two forces, a 500 Newton force and a 300 Newton force. And then we're going to do another problem over here, which is the couple part. There are three different couples here, the red, the blue, and the green. And so here's a bunch of equations that we're going to need to use. And I wrote m equals df twice because there's two separate ones, really. There's the original, the common one for moments is m equals df, the distance times the force. But there's a special one for couple, so I just wrote another one just to signify that there's really two different ones. They're the same, but it's kind of special for a couple, and so I wrote it twice. But we're going to start with the first one, force. And so, well, what the question is, right, is it wants us to find the moments around point O. Okay, this is point O. And so what we're going to do is we're going to sum those moments. Okay, so what I did here was I wrote the sum of the moments around O, right, is equal to, and I'm going to write all the moments on this problem. And so this 500 is the force. Okay, this right here is just the m equals df. This is our d and this is our f. Okay, that's what this is. It's the moment of this force around point O. And so this is the force, and this is the distance from point O. And this force is causing a clockwise moment. Okay, which means it's negative. The next one is a little bit trickier. So we'll do the x portion of 300 first. And this, just to be clear, this triangle right here, right, it's 1 and 1. There's a lot of different ways you can signify that these are 45-degree angles, but what I just did was put 1 and 1 on those sides, just to tell you that both of those sides are the same size, the same length, which means that this is a 45, 90 triangle. And so what we're going to do, we need to find the x of this and the y of this. Okay, and so the x is going to be which cosine and sine are the same, but when it's taking a 45, but we're going to say we're doing this angle, so we're going to take the sine 45 times 300. Okay, so I switched it up. This is the distance now, or no, I'm sorry, this is the force, yes. We're going to multiply that by the distance, which is 2 meters. Okay? Because this is the x portion, right? So the perpendicular distance is 2. It's positive, right? Because it's creating a counterclockwise moment, which means our moment is positive. And so those are the first two terms, right? And it's kind of deceiving. There's two forces, but really there's three, because we're going to break this into two. So we're gonna subtract the next moment because it's a negative moment. We're going to do the y-axis version, the y coordinate version of this force, which goes like this. So it's going to create a clockwise moment around O. And so the force of this is cosine 45 times 300, right? And the distance is 0.5 meters. Okay? That all equals 0. I think that's my problem. So this isn't an equilibrium, right? We're not saying that this equals 0, okay? I'm sorry to, we don't even need that equation, really. I should have clarified better, but what we're doing here is we're summing moments around O. So we're figuring out what these forces are producing moments, right? Because they're not parallel, they're not pointing at O. If they were pointing at O, there would be no moment. But there's some sort of torque, and so that's what this moment is. We're just summing that torque. And so when you do, what you'll get is negative 2,681.8 Newton meters. Right? That label is Newton meters because we're taking newtons, the force, times the distance, which is in meters. Okay, and this negative, right? It just signifies that it's clockwise. Okay, so if this was a pin, right, it would be spinning like this. Okay, if it was. For the sake of this problem, we don't have to determine if it's a pin or not, or what it is. All we need to know for this problem is that it's at equilibrium. It's not moving right now, and we need to determine if it would be, what is the moment around this point. And so this is the moment around that point, and that's the direction it's going in. Okay, so we're done with this one. This is the answer. The second one, couples. So I said earlier that couples have their equation right here. This common equation is a little bit different. It's a little bit more convenient, actually. And so a couple, I should explain, is a force that's two forces that are parallel to each other, right, in opposite directions that are equal. Okay, so these 300s, they're equal forces that are parallel with each other in opposite directions. Same with the blue and the green. And so it's the same process here. What we want to determine is the moment around point O, which is right there. Okay, so we're going to sum all the moments around point O. Except we can do it a little bit different because we know these are couples. Okay, and so this little equation right here, we just took the distance times the force. Okay, over here we're going to take a different type of distance. Okay, this distance is the perpendicular distance between the couples. Okay, right? It's not from the point to the force, it's between the couples, right? And the force is just the force of one of the couples, force of each couple, right? So the force of the red would be 300, not 600. It would be 300. It would be the force of one of them, right? Okay. And so for the first one, I'm going to write it out actually. Okay, so what I did here, this is the 300, the red moment. It's the force of the moment. I'm sorry, This is the red couple, okay, which is producing a moment. The force is the 300, and the distance between the two is 5. And it's negative because it's spinning clockwise, okay? The 400 is counterclockwise, so it's positive, and the distance between the two blues is 2. The 200 is clockwise, so it's negative, and the distance between the two is 0.2. So when you do all that math, you get negative 740 Newton meters. Okay? And again, this negative just says that it's clockwise. That's all it signifies. And so that is how you determine a moment from a system of forces and a system with couples.